Thank you, everyone. Thanks for coming. For those who don't know who I am, I'm Nick Schrock, and I'm the CTO and founder of Dagster Labs. And thank you all for coming. It's always gratifying to see how open source projects and technologies are truly a worldwide phenomenon. That is always very cool. So thanks, everyone, for telling me where you're from. So today we're here to talk about components, which is a new technology that we're developing here at Dagster, and it's going to be in a preview state. But it's really a foundational technology for Dagster that's going to change the way that the product is used. So it's both a new modular architecture for all of our products, but it's also a pathway to a more accessible product built with a first-class YAML DSL built on that foundation. We really think it also lays the foundation for the AI era in data pipeline. We've really built this framework with this new era in mind to be an ideal target for AI-driven code gen. And critically, we are doing all this while keeping great engineering in mind. Low code and AI are typically associated with fragile systems and slop and errors and bugs and non-scalable solutions. But we believe we've really struck a novel trade-off here, allowing data platform teams to have the best of both worlds. So what is that trade-off? What am I talking about? And we like to frame it in terms of the trade-off between accessibility and power. And let's go ahead and define those properties and explain why they're important. So the first one is accessibility. We define accessibility as the ability for practitioners to self-serve, to build and operate data pipelines. There are many technologies, many tools, many different types of people that use the platform. You want those folks to be as close to the business and the people that rely on their end products, the data assets, as possible. And you want them to own and self-serve those data pipelines directly as much as possible. This matters because without this property in a data platform, there is an enormous coordination burden between the business and the engineers. The users that know the business, the subject matter experts, need to communicate requirements to the engineer. They need to ensure those requirements are implemented correctly. They need to get the engineer's time and attention, competing with all the other subject matter experts who have the same incentives. And really everything grinds to a halt. Self-serve, I think, in the modern age is essential for data platforms at scale. So you need a powerful data platform. And I think the way I define that is a platform that allows you to scale data engineering across the organization and can do so in the context of a world that is constantly changing, both in terms of business requirements and an evolving landscape. When you can scale data engineering across the whole organization, the data platform team becomes leveraged and become leveraged through applying engineering best practices at scale, automation, and other in cross-cutting process. And this matters because this means that the leveraged data platform team can drive organizations spanning outcomes. You can productivity improvements, enforcing standards programmatically, doing cost reduction across the organization, deploying new technology, cross-cutting policy initiatives. The alternative to a centralized data platform team doing this at scale is manual, burdensome, heavyweight process that requires an amazing amount of coordination, and those efforts typically fail. So this is really the story between two personas in the organization. One is the data practitioner, that subject matter expert. They go by many titles: data scientist, analytics engineer, and researcher. And I think what we typically see is that they use a single domain-specific tool, and they want to stay within that tool and environment when running their business logic. So this could be dbt for an analytics engineer, a notebooking platform for a data scientist, and so on and so forth. And the other person is the data engineer, or in some organizations, we find this increasingly true, they're called the data platform engineer. They know a ton about technology and engineering process, and they often or typically have limited or even no context on the core business domain. And the people who could fulfill both of these roles are extremely rare. They are unicorns. And hiring for unicorns does not scale. I've always found that phrase a little funny because unicorns don't actually exist, but I don't make the rules in English. But just the amount of knowledge and context you need is too great. And so the way I think about this is that the only way this works is if you organize your teams around the right systems, both technical and organizational, with the right abstractions in place. And when teams collaborate on systems, you have APIs, and those aren't just the interface between pieces of software, they are also the interface between teams. And you have to get this right in order for the platform to scale. Okay, so the approaches we see to achieve self-serve data pipelines are the following that we see. One is you implement a verticalized low-code tool or platform, such as Azure Data Factory, Informatica, that sort of thing. And the goal here is to effectively remove the data engineer, the platform engineer, from the loop entirely and rely exclusively on a vendor tool for self-serve data pipelining experience. However, we find this approach is not powerful or flexible enough once you go beyond the most basic needs. Next is what I'll call a engineer-only production stack. While this can work and is more adaptable, it often fails to serve the practitioners, subject matter experts, and stakeholder teams. So Airflow would be in this category, as well as other kind of pure Python systems. And the result are poorly structured systems that end up with accessibility problems. And the last common pattern we see is to, quote unquote, fix the accessibility problem by building bespoke tools, frameworks, and DSLs stacked on top of that orchestrator. This ends with a road with fragile, brittle tooling that, again, leaves us with a platform that in reality is not that accessible, not that powerful. So how does this journey unfold? So let's go through an example of how this would work at a big company. Imagine you're just getting started. You bring in this siloed all-in-one tool because it demos well and people are happy at first. However, as I mentioned, it's not powerful or flexible enough. And what happens is that core mission-critical pipelines start breaking, and you have to hire engineers who often end up building parallel infrastructure for those pipelines. And that results in a siloed data platform, and effectively the low-code tool is not scaling. And the situation is untenable because for the core business, the engineers become the bottleneck. The practitioners, in fact, can't really do their work, and everyone is unhappy. And this might be a 2 or 3 year process to go through this. Next, the data team is in crisis mode. They need to make a big change. They decide to adopt Airflow. Sounds great, right? This is a more structured system. It's in Python. You can integrate with the company's infrastructure, get observability, integrate into the broader platform. That's all great, right? So it's definitely an improvement for this company. However, it starts to go wrong as it scales. They onboard the practitioners, and Airflow kind of tries to satisfy both constituencies and fails to do so. It has a lightweight structure so that you can just churn out Python and have it be automatically picked up by Airflow. You have one single file where you auto-discover all the DAGs. It is not really optimized for a software engineering lifecycle. In the end, as it scales, the data engineers can't truly build an effective platform. And in reality, many of the practitioners try and fail to onboard onto the platform effectively. Now, what teams do typically is a couple of different things. Sometimes they try to split up the platform into a bunch of Airflow instances, and that's a different platform problem. What this company has done is they effectively had to have the central data team had to take back over the central Airflow cluster. And they become a bottleneck, right? They're the ones who have to build the data pipelines and integrate and productionize all the flows. And ironically, we're left in a state with similar trade-offs as before, meaning that centralized data team, unhappy. The practitioners are also unhappy. They can't self-serve. There's shadow IT initiatives. And again, we're stuck where we are. And 2 years in, something must be done. So an ambitious engineer has a bright idea. And they build a custom bespoke framework or DSL, like a YAML DSL or a higher level Python API over Airflow. And again, this demos well, and the initial use cases seem great. But the issue is that this is actually a difficult piece of software to build once you actually start using it and having to debug things heavily. They have limited tooling, they're difficult to debug, and maybe that ambitious engineer moves on in his or her career. And now you're left with this unowned thing with maddening usability problems. Again, the practitioners are unhappy. There's a data team that has to maintain this piece of software. They don't know how to deal with it. And 2 years later, we're basically back to where we started. Maybe a little better, maybe a little worse. And we see this cycle over and over again with our customers. There's a line, there are decades when nothing happens, and there are weeks where decades happen. And it's actually attributed to Vladimir Lenin, but he could have been a data engineer at this company, because effectively they're making critical technology decisions that have long-term implications in a matter of weeks. But then they go on for years, and nothing happens. And that's a really frustrating state to be in. So we're dealing with excruciating trade-offs, as I said here. You can think of it, I apologize in advance for having an MBA-style grid, but I can't help myself. And we have this grid where it shows trade-offs between not powerful and accessible and not accessible. So they initially adopted a low-code tool. I would argue that it's accessible, but not powerful at all. Then they adopted a DAG-only tool that's Pythonic, like Airflow or Luigi, more powerful, less accessible. And they try then to build this bespoke DSL, right? Which kind of moves you along in this grid, but doesn't change the game. I also want to call out, there are more modern low-code tools out there, which are improvement over the legacy ones. And they move up in accessibility and power, but I don't think they fundamentally change this equation. And this kind of is from an economics lens. You can think of it as a power accessibility frontier, where because of the technological progress, you're stuck below this line. You have to pick a place below it, and it's always doesn't feel great. And our goal, not saying we're there yet, but our goal is to be in this upper right quadrant. I bet many of you could have predicted the outcome of this slide build. This is where we want to be. Our goal is, as we develop the system, is to push this up and to the right. And so without further ado, I'm going to actually hand it off to Colton, who works in community engineering here, and he is going to demo what this experience would look like from the standpoint of a practitioner onboarding onto a components-enabled platform.
Thanks, Nick. In this demo, we have an existing Dagster instance. You can see we have some Delta tables in Databricks. We have this user's augmented asset that's calling out to OpenAI to augment that user data. And then we have these 3 assets that are running in Kubernetes. I know that my data platform owner has created a Kubernetes component for us to use, and I've been experimenting with Python, and I want to get my code into this platform without really understanding the underlying concepts of Dagster. So what I can do is I can go to the deployment tab, I can click on my code location, and we have this new tab here called Docs. And you can see the different components that are available in this instance. I'll zoom in even more just to make sure it's clear. And I'm interested in this Kubernetes component. And here you can see the data platform owner has actually documented this component for me to use. It says, this is the officially supported method for running custom analytics and processing jobs in Kubernetes for this Acme organization. It also has a scaffold command that I can run to get up and running. And then we have automatic documentation generated for the different attributes you can provide for this component. So here's an example YAML spec. And you can see you can set different attributes on the asset itself, as well as these custom DSL attributes that my data platform owner has defined. So they have enabled me to set the image and the command that's running, as well as some configuration of the Kubernetes pod. What I'm going to do is I'm going to copy this command and then go back over to my editor. And in the terminal down here, I'm going to run that. But before I do that, I'm going to show you, here's my experiment.py script. Right now, it's just a standalone script. If I go under source defs, you can see we have a couple of other components that are already existing. So we have Bob's experiment, and you can see within there, there's an analysis.py file, a component YAML file, a Docker file. And then we have Jane experiment, and it's the same thing. And that's because they've scaffolded these components, and the data platform owner has made it so that these files are automatically generated. What I'm going to do is open my terminal and type dg scaffold Kubernetes component. And I'm going to create a new one called Colton experiment. And just like that, you can see over here in the sidebar, now we have another experiment, Colton experiment, and it has its own component YAML file and analysis py file. And I'm just going to take my code, copy that, and paste it in here. And now I have my code in this component, and I'm going to customize this component that was generated. And again, the data platform owner made it so that it was predefined to have all these different attributes. And I'm going to go and rename this just to say that I'm the owner. I'm going to save that file. I'm going to go back into my Dagster instance and reload those definitions. Cool. So just like that, I scaffolded a component, and you can see I have this Colton experiment asset. But the problem is it's not downstream of users augmented, which my script relies on. And I'm going to try to figure out why that is. So I'm going to see what Bob did in his component to see if I can infer how he was able to configure that. So I'm going to go to the component YAML for Bob. And right away, I can see he set this dependency attribute. So I'm going to copy that, bring it over to my component, and paste it in. And I also just remembered that my script does more than just generate one asset called component or Colton experiment. It generates a user's augmented dashboard, and it also creates a report. So I'm going to copy this whole thing and paste that and rename this one users augmented report. And to close this a little bit, you can see now I have two assets defined in my component YAML. I'm going to save that, go back over to my Dagster instance, reload the definitions, and just like that, now I have my custom experiment script downstream of the user's augmented table without writing any Dagster specific code, just the component that my data platform owner provided me.
What you saw here was basically a practitioner coming into a project and effectively via cargo culting and just scaffolding up this component in a project, being able to, in a single command, get something up and running. And there was robust tooling and integrated documentation. And then one thing I think is really cool is that the data platform engineers were able to define like custom scaffolding, which is so common in data platforms. Like with this one scaffolding command, they got a Docker file that was defined by the data platform team and another config file and a shell for the Python script that they needed to put in there. And it was very straightforward to integrate it into the broader platform. Innovation doesn't happen in a vacuum. It happens in the context of the industry. And I bet you can predict what I'm going to talk about, and you might be sick about hearing about it, but AI is coming. And even if it lives only up to a fraction of its promise, I like to say that there's a space between AI doomer and AI boomer, meaning like AI doomer is like the machines are going to take over, and AI boomer is this is just the same thing as before. I'm in the middle there, but that would make it a shift as big as the shift to the internet or the shift to cloud. And when you're making critical technology choices, you need to be thinking ahead. So the question to ask is, where does components fit in? I'd like to frame this briefly in the context of the broader ecosystem. I think that we can define the first era of data as the sort of 2006 to 2016 on-prem big data era, defined by technologies like MapReduce and Hadoop and data lakes. And effectively the challenge there was that there was a new unprecedented scale of data produced by internet scale data and digital native business processes. And these technologies were built to just make data processing on those data sets even possible. The next was the modern data era, defined by the shift to cloud and the development of the cloud data warehouses. And then this whole new set of tools, collectively known as a modern data stack, really was the driving force data teams for a good long while, especially the ones who were early adopters. And now we're just entering the era of AI, pardon me, the AI of AI. We're just at the beginning of this, and we don't know the complete set of technologies that will define it, but we'll know a couple, right? AI-assisted engineering is here, and it's being broadly adopted. And really the lake house, which is effectively, I describe it as getting cloud data warehouse like performance, but over a open table formats in a data lake, but also with heterogeneous compute and unstructured data, which is critical to these more advanced ML AI use cases. And then who knows what else is going to come out. We do live in exciting times. And AI is mainstreaming now in software engineering. Tools like Cursor and Copilot already have 1 million plus users. A couple years old, has $200 million in revenue, right? These are at scale businesses. And I think like tools like Model Context Protocol, which is the standard for getting context into tools like Cursor or ChatGPT, they are exploding in popularity very quickly as well. And it really hit an inflection point in March. If you just look at this as a Google Trends chart, and what happened effectively is that a bunch of people started building MCP servers, and then OpenAI adopted the standard. And it was originally produced by Anthropic. And once the two industry titans agree on something, it went to the moon. And what's awesome about MCP is that you no longer need to build completely vertically integrated experiences to deliver AI. You can plug right into an existing ecosystem. So even if you're an AI skeptic, even if you think it's bad, the reality is that it's coming. People who just want to code and do it with AI CodeGen will be operating in your data platforms, whether you like it or not. And there's massive risk in this approach. We actually have a fairly conservative, constrained view of this era. We think there's a lot of opportunity, but it's very perilous. And we don't think software engineers are going anywhere. It's extremely easy to introduce bugs that are difficult or impossible to understand. It's what I like to call a technical debt super spreader. There's a lot of claims it's going to eliminate software engineers. I think that's completely bogus. I think it will make their work even more important because there's enormous value in containing the complexity explosion that will result in more people programming and spreading code throughout a code base. And the wrong person working with AI without guardrails is dangerous. And I think you all know how this goes, right? I call it shadow AI, using AI tools without it formally being integrated into a platform. You go to ChatGPT, you ask it to churn out a bunch of Python, you slap that in a pull request, some other person looks good to me, and all of a sudden you're pushing privacy violations and very costly mistakes. And this is going to play out over and over again. And the core problem is that natural language is an insufficiently precise input to produce reliable software in a completely supervised manner. And who said that? I said this. We wrote an article in the summer that was called The Rise of Medium Code, but you can think of it as low code plus great engineering. And it was written in the context of this discussion about, are software engineers even necessary, which I think was actually a silly discussion. But what it's really about is the properties of systems that will be effective in the AI CodeGen world. So the other point I'll make is that data engineers can have nice things too. The developments in data engineering in the last 10 years or so can be defined by taking the lessons of software engineering and applying them to data platforms. And components, we think, is really the first AI optimized framework for data engineering. So what does something need to do to be AI optimized? I'll start with an example. I actually think tools like notebooks and tools like dbt have a bunch of the properties of an AI optimized framework. They have two properties. One, they have these modular code containers where a business user can put in logic and have it be self-contained. And second of all, is a constrained target language. That practitioner can understand, debug, and operate, right? These are bicycles for your brain, not replacements for them. And components in Dagster, we try to have fit those same properties, right? This is a case where there's a YAML front end for it, but it also supports Python for those of you, and I can understand completely, who don't want to type YAML. But this is really the self-contained kind of unit of complexity that a single practitioner can fit in their head. And guardrails are essential. The modular code containers, it has what I'll call a technical blast radius for AI slop, right? You have a metadata-rich container, and if it's misbehaving because someone did AI in it, you can understand it and rip it out. It limits the necessary context windows for AI to operate. This is why it's good for humans too. Humans have context windows, and what's good for the goose is good for the gander here. And it ends up being more replaceable too. To take the DBT example, if someone produced a bunch of malformed, low performing DBT code, someone else can hop in, understand what's going on, and maybe rewrite it manually. But the whole system carries on without a hitch. And then this constrained code gen target's also important. So SQL, YAML, a superstructured framework that uses a subset of a target language, highly amenable to code gen. Humans should be able to evaluate the correctness of this thing because that's utterly critical. And the engineers and tools can enforce constraints, which is super important. So the Dagster component stack really tries to encapsulate these lessons. Just like any traditional orchestrator written in Python, it integrates with mainline infrastructure. And it's built on this sort of modular structure and framework that we developed that kind of subdivides your project into component parts, hence the term components. On top of that, we have out-of-the-box components with pre-built integrations for common technologies, but also the ability for your data platform engineers to write custom components in Python. So it's very accessible to write custom components, and then the DSL on top of that. And then we have tools and ecosystems that help everyone along with that, right? So it's this layer cake, flexible layer cake that we think is well structured for this future. What gives us the right to call ourselves the AI optimized framework for data engineering? And we think this is because the data orchestrator occupies a unique space in the data ecosystem. It's a unique hub of context. We're the only tool that knows what integrations you're using, the source code of everything you're doing, lineage, metadata, operational data, right? We can assemble tons of context for the user. In this case, it's for authoring use cases, but we think operational use cases as well. We have this framework that has guardrails, as I just went over, right? Modular components defined in a high-level introspectable DSL. And we have visibility across the entire lifecycle, from local dev to test to CI, to our branch deployments to deploying to prod. So we can impose constraints along the entire lifecycle. And with that, I will pass it to Colton.
Let's demonstrate using the custom Dagster MCP server with Claude Code for working with an existing Dagster project. In this project, you can see we have Sling replication for some CSV files containing data of customers and orders. And then we have DBT modeling that creates models for those customers and orders, and then a summary table of customers combining the two. I'm going to switch over to my terminal here. And on the left, you can see I have an editor open. Right now, I have the replication YAML for our Sling replication. I'll open up another terminal down here, and I'll also show you in the data folder, we have another file that we want to start ingesting called raw payments. On the right, I'm going to first ask Claude to tell me more about this Dagster instance. So I'm going to say, what definitions are available in this Dagster project? I should also point out that at the top, you can see it found one MCP server. That is the Dagster MCP server. And it was able to detect that it needs to use the Dagster MCP server and called the list Dagster definitions tool. So it prompted me to run that tool. You can auto accept the responses if you want, but for this demonstration, I'll just accept each tool call that it makes. But you can see it responded with, this project has several Dagster assets. It has some file assets related to the raw customers and raw order CSVs. It has some DBT assets and it has some Sling assets. So I'm going to say I have a new data file, and it's data/raw payments.csv. Can you update the Sling replication to ingest this data? And then can you update my DBT models to include this payments data as well? And this is a multi-step process, so it should prompt me to do several things, but to start, it's just reading those existing files to better understand the syntax and how they're defined. And There you go. Look, it looks like it determined that it needs to update the replication YAML file. Because with components, it's self-contained, the scope that it needs to search is much more limited, but it was able to determine that it wants to create an object or a stream for this object called main raw payments, and it'll point to that raw payments.csv file. If I go back over to the editor, you can see it was updated. And now it determined it needed to update the sources.yaml file for DBT to include raw payments. And it looks like it was able to infer that it needs to create a staging payments table. That looks good. We'll see if it has the correct column definitions for the CSV file. I didn't check see if it updated or it read that data to know that. And finally, it looks like it's updating the customers.sql and joining on that new payments data, which is great. So I'm going to accept that change. And now it's calling the Dagster MCP server again. So now it's doing the check Dagster definitions to verify that the changes that were made are correct. And it looks like it returned all definitions loaded successfully. And finally, we have the summary here saying, I've successfully updated your project to include the new payments data by adding the file entry to the Sling replication, adding the source DBT, creating the staging payment SQL, and then updating our customer.sql. I'm going to go back over to the UI here and reload my definitions. And as you can see, now we have this raw payments data feeding into our customers model. I'm going to go ahead and click Materialize All. And now it's running those Sling replications. It's running our new DBT models, all without writing any code ourselves. It was able to infer from the project structure and through the DG MCP server the changes that it needed to make. Great, so it succeeded. Now I'm going to say, can you query the DuckDB database and confirm that the new tables were populated as expected? So it looks like it's running the DuckDB command on that Jaffle platform DuckDB file. And we can see we have our raw payments, our raw orders, our raw customers, all of that loaded successfully. And it's going to have us run the DBT command. I'm not going to do that for now, but I think that was a good enough demonstration of the power of using Cloud Code. Thanks.
You know, we think the data platform is actually a uniquely good AI use case. We have a bunch of diverse practitioners who all need precise outcomes: analysts, data scientists, engineers, etc. There's a super wide surface area in data platforms, tons of tools, tons of configuration files you have to look up, highly amenable to LLM code gen. And there's also a bunch of what I'll call tribal knowledge in the company-specific integrations, legacy tech, uneven documentation. This can all be assembled and presented to the user with AI assistance. So the conclusion here, data platform teams have historically had to make an excruciating trade-off between leverage and accessibility. And we think components, you can get the best of both worlds here because it increases accessibility over this adaptable, powerful platform with a good abstraction layer between the data platform engineer and the practitioner. And components is really built for the future as an AI optimized framework that I would say takes a conservative but empowering approach to AI, knowing that AI slop is a real problem and you need to build systems that work, but it can be a powerful productivity tool if given the right constraints. So what's launching today, we're getting early access to components for select partners. Comes with integrations for initially embedded ELT, DBT, and pipes. And then coming soon will be a full components AI experience. This is a presentation of the vision of this thing. And if you want to learn more, you can come request a demo, and we also have a Slack channel. And with that, we can take questions. So I can just start reading them out. Nikita says, can we start using this already? He sent that directly to the hosts and panelists, so he really wants an answer. Pedram, you raised a hand. Yes, you can start using it. It's still quite early software, so we recommend you come to the Slack channel so you can give us feedback and report bugs, and we can consult with you. So we do have this out in the wild, as well as the new command line, the CLI, DG, and the new project layout. There's a ton of exciting stuff happening, but Let's come to the Slack or request a demo. Steven asks, do the docs explain how to make the popular LLM copilots make use of Dagster and CP? As I said, this was like kind of in terms of the AI, this is a preview of the vision, but certainly we will have not just docs, but hopefully some tools that will enable automatic generation. We actually have also ambitions to make it a place where you can integrate MCP servers for all the constituent integrations as well. So that's super exciting too. We want to make it easy to use LLMs and also to give it the right prompts and context that will also be pluggable. I'm very excited about that framework as well. Let's see here.
Yeah, we have quite a few in the Q&A. Another one from Nicholas says, is this a Dagster plus only feature?
No. So the components framework is open source. The new CLI is open source. And what you currently saw is integrating the open source.
Yeah, we have another question that says, how can we join the early access to the AI functionality?
We will stay tuned, I would say. I would hang out in the Slack channel and we will announce when it's ready for more public consumption.
Yeah, we had another similar question.
The eager questions make me want to prioritize it more. So that's good news for you.
Yeah, and we had a similar question asking about the Dagster MCP server. When will it be publicly accessible? And that's in active development, and it'll be a part of the DG CLI hopefully pretty soon. So also keep your eyes peeled for that.
Chris has a great question in the chat. Chris Wigmore. How do we avoid the engineer bottleneck? The goal here is that the vision here is that you can send out a link to one of your stakeholders and they can then clone the repo. They'll be able to see what's going on, see what component types are already there, browse the documentation, scaffold and onboard without having to talk to the engineers or a very limited amount, and instead working through the integrated documentation and tools. So the claim here is that because of the higher level of abstraction and the tooling ecosystem, that practitioners will be able to onboard and self-serve without having the engineers either productionize it for them or handhold every step along the way.
There's a question here that says, is this AI tool going to blow up my open source deployment if I use it? Is my server going to do a bunch of inferencing?
The objective is no, I would say. The AI tools we showed are all code gen, right? So these are read-only operations. They generate code. It goes through your CI/CD pipeline. It goes through all your current process. And the objective of components as well is that each individual component provides its own kind of compartmentalization of complexity. Because what terrifies me about AI is like it arbitrarily going into a code base that isn't particularly structured and just splurging everywhere, right? This provides like a contained area where stuff can happen. And this is not doing any sort of runtime inference or kicking off any mutations.
Yep. And this question asked about, can we use our own models if it's like a security concern to send your code to a different like third-party company for the LLM? And yeah, the MCP server is a standard protocol, so it should be supported in any agentic workflow that you're using. And there are some which you can use your own open source AI models. So we're just providing an MCP server implementation that you can then leverage. We had this question asking, how are assets different to components? And that's an interesting question. I like to think of components similar to factory methods. If you've done that paradigm in your Dagster code base, where you create a function that returns definitions, including assets and other things. So essentially, the component can encapsulate the assets that you want to generate.
Yeah, fundamentally, a component's a higher level abstraction that is a function that produces arbitrary definitions, which could be assets, could be asset checks, could be sensors, could be whatever. So it's a very flexible specification. Does it make sense to use components for simple assets that fetch data from an API to blob storage then? So you can, in this new project layout where kind of everything is a component, you can slap an asset decorator in a file and it like fits into the component system naturally. So this is a layer on top of all our existing abstractions rather than a replacement for them.
Jacob asked about seeing a DBT component. If you actually go to our documentation, on the left-hand side, there's a labs section, and we have a components ETL tutorial that shows how to use Sling, DBT, and then evidence for dashboarding. So I think that would be a good example.
Daryl, I think the way I would view components and assets is that components are a way to organize the assets that are in your project layout. Colin asked, and I answered in the chat, but I'll say it aloud, where is the scaffold template stored, in GitHub or within Dagster? So you could say it's in GitHub because it just lives alongside the Python code. So when you install the package, you get the scaffolder for free. And that means you can write your own scaffolder as well, which is what Colton demonstrated when it was producing the Docker file that was particular to your platform.
As a reminder, we also have a Slack channel related to webinars and deep dives, so I encourage people to hop on there. We also have a Slack dedicated just to DG and components where we're sharing more details as we evolve the product. So if you want to stay up to date on how we're doing that, I encourage you to join that channel. We're also going to upload the recording of this webinar, but I think that's all we have for this one. Anything else to say, Nick?
No. Thanks everyone for coming, and thanks for all the engagement. It's great that everyone's asking questions.